Hey everyone, I'm Niroshan. Today I'm going to demonstrate about my applied project which I have completed as part of my computer science master's degree in Harrisburg University. So my project is DSL for visualizing climate data, and I'm going to talk about the problem statement and what is a DSL and DSL background, examples, advantages and disadvantages, and we'll focus about then my DSL design. Problem statement is weather data are big data that are extremely large in size, variability, and velocity. Their complexity has made it difficult to collect, analyze, process, interpret, and understand data by a traditional programmer or data scientist or even a general user. Weather data are comprised of historical and real-time data that are widely analyzed by decision makers in predicting and resolving problems varying from state level to individual daily tasks. For an effective representation and visualization of weather data, this project will attempt to develop the data visualization tool by developing a domain-specific language using mainly Python 3 programming language and other program developing tools and so many resources. So what exactly is a DSL? Why we should use DSL? There must be a reason. So DSL denoted as a domain-specific language, which is an advanced language, and also is a programming language that can be developed to accommodate defined needs of a particular domain or platform. So what exactly a domain means? A domain can be a system, it can be an industry or business or even a problem in an area of interest. The main important facts about DSL is that it is one of the most recognized technique to provide solutions for many software engineering problems. DSL has the ability to perform domain-specific tasks, which contains domain-specific grammars and syntaxes. While developing a DSL, we need to focus three main factors. The first one is a DSL should deliver a direct mapping to the objects of the problem domain. And DSL must contain standard grammar syntaxes for the problem domain. And syntaxes should be meaningful for the domain, which can be used to communicate between domain experts and developers. Finally, the DSL must be designed and implemented to avoid as much as its complexity. That's why it's called DSL. So what are the DSL examples in current world? There are so many DSL examples. I have listed few common ones here. So the first one is SQL, structured query language, which is a DSL for the database domain. You can create databases, insert data into it, you can retrieve from it. So all the database functionalities can be handled by using SQL DSL. And also you can use HTML, CSS to design web pages or create web pages and so on. Then UML, Unified Modeling Language, we use UML tools to create use case diagrams, ER diagrams, sequence diagrams, and likewise. And also XML, JSON, you can use those DSLs to data encoding, decoding, data transfer between different operating systems, different languages, different applications, and all. And the YAML file, if you ever worked on REST services, probably you might end up with using OpenAPI tool. In OpenAPI tool, you will create a YAML file, which eventually you will end up with creating interfaces, classes, and data transfer objects by using YAML file. So there are so many DSLs that we can use it in our current world. So what are the advantages and disadvantages? There must be advantages to use a DSL technology. So the first thing is it is easy to analyze. So the DSL is implemented in such a way that it will handle all the corner cases or the negative scenarios and all, and it will throw meaningful error messages or meaningful warning messages which domain experts can understand. Therefore it is easy to analyze, and it is safer. It won't throw null point exceptions or class not found exceptions. Likewise, it only gives meaningful error messages which is specific to that domain. Therefore, that errors speak the domain language itself. And you can use the DSL in any operating system, therefore, it is easy to port. And the main thing is you don't need to have like a computer science background or programming background. Therefore it is easy to learn because domain expert can understand those syntaxes and error messages because those speak the domain language itself. Data visualization is an efficient and powerful technique in big data analysis, which allows people to understand, identify, read, and compare scientific data in more accurate and meaningful manner. Having a graphical representation instead of a textual representations would be more helpful, as the human brain can process visual elements faster than textual elements. However, visualizing large data into a graphical representation is more challenging task for a normal user. Even a senior programmer won't be able to understand or read scientific raw data and use them to visualize meaningful graphical representation at the first glance. So in this project, I have developed a climate data visualization model, which is a graphical representation of weather data. So in general, weather data are usually scientific big data that are not user friendly or readable and complex to use in regular manner. To obtain multidimensional graphical output using these data will require special and sound knowledge about scientific weather data patterns or methods as well as programming knowledge. So my goal is to develop a user-friendly tool using DSL technology which make it easier for domain experts to read and interpret data. So here's a NetCDF file which is the format I'm using in this project, and so by looking at that you can understand that how complex it is. It is not readable at all, so it's not user friendly, and it has thousands of lines of data and variables, multi-dimensional arrays and all. So it's so hard to read and get any information out of it. So here's a main use case for my design. So it has three main actors: programmer, weather data scientist, big data analyst. The main difference between programmer and other two actors is programmer can add more modules, enhance those modules, enhance this DSL, so programmer has more access. There are few modules I have implemented as part of this project, so which are view a quick plot, sounding plot, pressure diagram, 2D wind speed diagram, 3D wind speed diagram, creating a NetCDF file with manipulated data, view georeference plot, view global sea temperature. Likewise, this is a sequence diagram. So as a user you will create a source file based on the syntaxes, and then you will run the source file against the DSL compiler. So DSL compiler will check any syntax errors or any validation errors are there. If there are any errors, it will throw meaningful error messages. Based on the error messages, user has to correct those errors in their source file and run it again. If there is no any error, then the DSL compiler will call respected module, and the module will import all the libraries and load all the libraries, import all the modules, and then it will retrieve the data and do pre-processing. and while doing those pre-processing, it has each module has its own validations, and based on the validation, if there is any validation error, it throws meaningful error message, and user has to again correct those and run it again. If there is no any error, it will gives a proper output. Here's a class diagram. So in the class diagram, the main thing is a climate data visualization DSL controller, which handles all the modules or the compilations and all, which is the heart of the DSL. And rest of the thing all the modules. It has its own functionality, methods and all. And this is how the class diagram looks like. So this is the DSL design. So let's look at the traditional way. The traditional way, you will have raw data and you need to write thousands of lines of code to do the data pre-processing. So in that data pre-processing, you need to write all the mathematical equations and all. So based on that, you will get output, and that output you will use different libraries to visualize it. So in the proposed DSL, we will consolidate all these process. You just need to use the DSL syntaxes and give raw data and use those modules to run and get the output. So all the data pre-processing, libraries, visual generating visual elements, everything will be centralized. Here's the proposed DSL architecture. So as a user, you will create a source code, and the source code will runs against the DSL compiler. The compiler has a code analyzer. The code analyzer will check all the syntaxes and all. Based on the syntaxes, it will do the data pre-processing. For that, it will use raw data, and based on the pre-processing logic and all, it will generate an output data. The output data, most likely it will be a multi-dimensional array. So based on that output, you will use Python different modules, different libraries to visualize this data. So here's the DSL architecture, and thank you for listening my presentation. If you have any questions, please feel free to comment, and I will create another video with the code, and I can run my DSL and show it to you guys. Thank you.